Section 7.1, problem number 4, tells us that overproduction of uric acid in the body can be an indication of cell breakdown. This may be an advanced indication of illness such as gout, leukemia, or lymphoma. Now, over a period of months, an adult male patient has taken 9 blood tests. Okay, I need to write this down so I remember it. N is equal to 9. 9 blood tests for uric acid. The mean concentration of these 9 tests is 5.36. Okay, so X bar is 5.36. And the distribution of uric acid in healthy males can be assumed to be normal with a standard deviation of 1.93. All right, so that's assumed based on past experience that the standard deviation is 1.93. So part A says, find a 95% confidence interval for the true population mean. And then what's the margin of error? Okay, lower limit, upper limit, and margin of error. So let's do this straight on our calculator. So here's what we're going to do. We're going to go to, if we can get it to right here, we're going to go to Stat. And then we're going to right arrow over to Tests. Or I guess you can left arrow for that matter, but we're going to go over to Tests. Then what you have to do is you have to scroll down to Z interval. Now which one is that? Okay, let me get back there. It's something here, but it's a Z interval. And it's a Z interval because we have a known, right there, a known standard deviation. Oh, and that is number 7. All right, so we'll choose number 7. Now, we're going to put in statistics. We're not putting in any data. We're just putting in the statistics, the numbers that have already been computed for us. And what it's asking us for here is sigma, X bar, N, and then the C level. All right, so in our problem, back up here, I need to get sigma. Now, sigma is known to be 1.93, so we'll type in a 1.93 there. X bar, okay, to X bar, that is 5.36, all right, so that's going to be 5.36. N was our sample size, and N, right, our sample size is 9. Okay, so our sample size here is 9, and our C level is 95%. So you can put in 0.95 or just 95. So when I computed my calculator to come up with this, it comes up in interval form, 4.0991 lower limit, and then 6.6209 as my upper limit. And it does say to, all right, there's rounding here. There usually is here. Round to 2 decimal places. All right, so let's go down here and round to 2 decimal places. So I'm going to write this now as 2 decimal places. 1, 2, well, that's a 9. I'm going to raise that up to a 10. That'll carry over. So how about 4.102, now 2 decimal places. 1, 2, okay. That just is a 0. How about 6.62? Right, so to answer the question then, the lower limit, okay, I'll do it right up at the top, 4.10. Upper limit, 6.62. Now let's get this margin of error. Well, the margin of error, that's how far we're going to be off. So what we're doing here is we built an interval that went from 4.10 to 6.62, and we're 95% sure that we've covered the mean, that the mean is in here somewhere. All right, so the margin of error is just going to be half of that. So it's going to be this number minus plus, okay, and that's going to give us our, and everything is built around what, that 5.36. All right, so let's get this interval length. Now the interval length is just going to be the 6.62 minus 4.10, and then we'll divide that whole thing by 2. I got 1.26, so I'm going to report that up here at the top. margin of error 1.26. Now part B says, what conditions are necessary for our calculations? Well, we didn't need n to be large, but we did need what? We did need to know that we had a normal, and it does say that normal distribution of uric acid, right? I think it says that up here somewhere. The distribution of uric acid can be soon to be normal. All right, so that is necessary if we're going to use this Z curve, so that one's necessary. Sigma is known. Yeah, we need that one too. Let's see, what's this? Uniform distribution? No, we haven't even talked about that one. Sigma is unknown? No, we have sigma. N is large. We can use N large when we have sigma unknown. But these are the two we need for right now. Now let's interpret this. So we got a 95% confidence interval. So what I'm saying here is that I'm 95% sure that this interval captures the true mean. So what do we have? The probability that this interval contains the true average uric acid is 5%? No, it's the opposite. We're 5%? No. We're 95% confident that the true uric acid level for this patient falls within this interval. That's what we're looking for. So I'm going to claim it's that one, but let's just read the last one just to be sure. The last one says, the probability that this interval contains the true uric acid level for this patient is 0.95. Okay, you know, this one here looks okay to me. The probability that this interval contains the true average uric acid level is 0.95. You know, I think they're just asking for one, and this is probably the best one. Okay, I'm gonna go with this one, but I think there's a good chance for this one here too. Way down here in part D, we're asked to find the sample size necessary to construct a 95% confidence level with maximal margin error of 1.06 for the mean. All right, so we have a formula for sample size for a mean, and that formula goes like this. It goes like this. N is equal to, I put it in a bracket, is your critical z-score that comes from your confidence level times sigma divided by the error that you're willing to make, and then you square that whole thing. Now, at 95%, this may be one of those numbers you remember, that gives us a critical z-value of 1.96. Remember those numbers? If it was a 90% confidence interval, it'd be 1.64. 99% confidence interval, 2.58, and so on. Okay, so we've got these numbers. So N is going to be 1.96 times sigma. Now sigma for us was the 1.93 divided by the error that we're willing to make, which is 1.06. And don't forget to square it and then round up. So I got 12.735, but I have to round up. All right, so when I round up, I get 13. All right, so our sample size necessary in order to construct this interval is going to be 13.